Hello, curious minds. Welcome back to Solar System's Wonders, where we explore the most intriguing aspects of our celestial neighborhood. Today, we're venturing to our nearest planetary neighbor, Venus. Often called Earth's evil twin, Venus is a planet of extremes, from its blistering surface temperatures to its crushing atmospheric pressure. Did you know that Venus has a day that's longer than its year? Stick around to find out why. Let's dive in and discover what makes this fiery planet so fascinating. It is the second planet from the Sun and Earth's closest neighbor. Known for its bright appearance, it's the third most luminous object in the sky after the Sun and Moon. Orbiting the Sun at an average distance of about 108 million kilometers, 67 million miles, or 0.72 astronomical units, Venus receives sunlight in approximately 6 minutes. With an equatorial diameter of about 12,104 kilometers, 7,521 miles, it is quite close in size to Earth, which measures 12,756 kilometers, 7,926 miles, across. When Venus is closest to Earth, it's about 38 million kilometers, 24 million miles away, but its distance can extend up to 261 million kilometers, 162 million miles, at its farthest. Interestingly, Mercury, the innermost planet, often comes closer to Earth than Venus. Now, let's take a closer look at Venus's dance around the Sun. Its orbit is similar in shape to Earth's. It's almost a perfect circle around the Sun, completing one full orbit in about 225 Earth days. Adding to the intrigue, Venus rotates incredibly slowly. It takes a leisurely 243 Earth days for Venus to complete one full rotation, making its day longer than its year. But why does Venus have such a slow and unusual rotation? Scientists believe that Venus's peculiar rotation could be the result of several factors. One leading theory suggests that gravitational interactions with the Sun and possibly other planets caused significant tidal forces that slowed Venus's rotation over time. Another hypothesis is that a massive collision with another celestial body early in its history altered its rotation. This slow rotation results in prolonged periods of sunlight and darkness, but the planet's thick atmosphere ensures that temperatures remain relatively uniform across the day and night sides. The slow rotation also contributes to the formation of its dense, swirling clouds and complex atmospheric circulation patterns. Additionally, Venus has a very slight axial tilt of only 3 degrees, which is too small to create noticeable seasons. Perhaps the most peculiar aspect of Venus's celestial motion is its rotation. Unlike most planets in our solar system which spin on their axis in the same direction as their orbit, Venus is a rebel, rotating in the opposite direction. This backward spin, known as retrograde rotation, is one of the enduring mysteries of Venus. Imagine standing on the surface of Venus. If you could withstand the extreme conditions, you would witness the sun rising in the west and setting in the east, a truly mind-boggling sight. Prepare yourself, because stepping onto the surface of Venus is like stepping into a blast furnace. The surface temperature averages a staggering 464 degrees Celsius, or 867 degrees Fahrenheit, hot enough to melt lead. This extreme heat is a direct result of Venus's thick carbon dioxide-rich atmosphere, which traps heat through a runaway greenhouse effect. It's no wonder that early Soviet Venera missions, the first to land on Venus, only survived for a short time before succumbing to the intense heat. We'll talk about that later, but the heat is only one part of the equation. Imagine the weight of an entire ocean pressing down on you. That's what the atmospheric pressure on Venus feels like. At 90 times the pressure on Earth's surface, it's equivalent to being 900 meters or 3,000 feet beneath the ocean's surface. The sheer weight of this thick atmosphere creates an environment so extreme that it would crush most spacecraft like tin cans. Beneath Venus's thick, obscuring atmosphere lies a surface shaped by intense volcanic activity. Radar mapping from missions like Magellan have revealed a landscape dotted with vast plains, towering mountains, and colossal volcanoes. Venus is thought to have a relatively young surface, geologically speaking, suggesting that volcanic eruptions have reshaped its surface in the recent past. Future missions with advanced radar and atmospheric sensors could help us determine if Venus is a dormant volcano world, or if its fiery heart is still beating beneath the surface. While volcanic activity has shaped much of Venus's surface, other geological processes have also left their mark. Despite the extreme heat and pressure, evidence suggests that wind plays a role in shaping the Venusian landscape. Imagine vast plains sculpted by wind-blown dust and sand, creating ripples and dunes that stretch for miles. Future missions, equipped with landers and rovers, could unveil even more secrets hidden beneath Venus's thick veil. So far, we've explored Venus's extreme surface and its unusual dance around the Sun. Now, let's use our imagination to take a journey to the center of this enigmatic planet. While we can't directly observe Venus's interior, scientists have used data from various missions and our understanding of planetary formation to piece together a model of its internal structure. Deep within Venus's fiery embrace lies its core, believed to be a massive sphere of iron and nickel. However, Venus's core is thought to be mostly solid. The intense pressure and heat at its center, combined with its slow rotation, are thought to inhibit the convection currents that drive Earth's magnetic dynamo. As a result, Venus lacks a global magnetic field, leaving it vulnerable to the solar wind, a stream of charged particles constantly bombarding the planet. Surrounding the core is Venus's mantle, a thick layer of hot, dense rock that makes up the majority of the planet's volume. Although we can't see it directly, scientists believe that Venus's mantle is rich in silicate minerals and is thought to be less active. Understanding this process is crucial for unraveling the planet's volcanic history, the evolution of its surface, and the dynamics of its atmosphere. Finally, we reach Venus's crust, the outermost solid layer, which forms the planet's surface. Compared to Earth's crust, Venus's crust is thought to be a single, unbroken shell. Without plate tectonics to recycle crustal material, Venus's surface is shaped primarily by volcanic activity, which resurfaces the planet over time. Future missions with advanced radar and seismic instruments could help us map the thickness and composition of Venus's crust, providing valuable clues about its geological history. Venus stands out as one of only 2 planets in our solar system that doesn't have any moons, but it does have a fascinating quasi-satellite named XUSV or 2002 VE68. Quasi-satellites, also known as quasi-moons, are asteroids that orbit the Sun but remain in close proximity to a planet. Unlike true moons, these objects have orbits that are more elongated and less stable. Over time, the trajectory of a quasi-satellite can shift, causing it to drift away from its host planet. XUSV's orbit around the Sun is particularly intriguing because it closely resembles a figure-8 pattern relative to Venus. This unique orbital path means that XUSV spends part of its orbit near Venus, while other times it moves farther away, making its relationship with the planet dynamic and ever-changing. Despite their seemingly stable presence, the orbit of a quasi-satellite can be influenced by gravitational interactions and other factors, causing it to eventually move away or even change its orbit entirely. Venus boasts more volcanoes than any other planet in our solar system, a testament to its fiery past and perhaps even a simmering present. Imagine thousands upon thousands of volcanoes, ranging in size from small domes to towering shield volcanoes that dwarf anything on Earth. While we know volcanoes have played a major role in shaping Venus's surface, a big mystery remains. Are any of these volcanoes still active today? Some scientists believe that Venus's volcanoes may erupt in episodic bursts, with periods of intense activity followed by long periods of dormancy. While Venus is now a scorching dry world, some scientists believe it may have once harbored vast oceans of liquid water. Imagine a time when Venus's surface was much cooler, with rivers, lakes, and perhaps even oceans gracing its surface. Early in their history, both Venus and Earth may have possessed similar atmospheres and surface conditions. However, Venus's closer proximity to the Sun set it on a very different evolutionary path. The escaping water vapor intensified the greenhouse effect, trapping even more heat and transforming Venus into the inferno we see today. Venus's atmosphere is a swirling, turbulent enigma. Imagine a thick blanket of carbon dioxide, laced with sulfuric acid clouds that rain down corrosive droplets, creating a truly hostile environment. Despite its toxicity, Venus's atmosphere holds clues about the planet's past, present, and perhaps even its potential for life. The study of its atmospheric composition, dynamics, and interaction with the solar wind helps scientists understand how Venus evolved so differently from Earth. One of the most intriguing aspects of Venus's atmosphere is the presence of a strange phenomenon known as superrotation, where the atmosphere circulates much faster than the planet's rotation. This rapid movement of atmospheric gases plays a significant role in Venus's climate and weather patterns. While the surface of Venus is undeniably inhospitable, the idea of life finding a foothold in its clouds has captivated scientists and science fiction writers alike. Imagine microorganisms, adapted to the extreme conditions of Venus's upper atmosphere, floating among the sulfuric acid droplets. This intriguing possibility stems from the discovery of phosphine gas in Venus's atmosphere, a potential biosignature that on Earth is associated with microbial life. Future missions with specialized instruments could search for other potential biosignatures, such as organic molecules, and shed light on the possibility of life in Venus's clouds. These missions could help answer fundamental questions about the resilience of life and the conditions that might support it, not only on Venus, but on other planets with extreme environments. The invention of the telescope in the 17th century revolutionized our understanding of Venus, transforming it from a wandering star into a world of its own. Galileo Galilei, one of the pioneers of telescopic astronomy, observed Venus's phases, similar to the phases of the Moon, providing evidence that it orbited the Sun. a key piece of evidence supporting the heliocentric model of the solar system. As telescopes improved, astronomers were able to discern more details about Venus, observing its thick atmosphere and even making early attempts to map its surface features. However, Venus's thick cloud cover proved to be a formidable obstacle, obscuring its surface from even the most powerful telescopes. Despite the challenges, astronomers persisted, using innovative techniques to peer through Venus's veil. They studied the planet's spectrum, analyzing the light it reflected to determine the composition of its atmosphere. They also tracked the movements of clouds in Venus's upper atmosphere, hoping to glean clues about its atmospheric circulation patterns. The mid-20th century ushered in the space age, opening up unprecedented opportunities to study Venus up close. No longer limited to Earth-based observations, scientists could now send robotic emissaries to this enigmatic world, equipped with instruments capable of penetrating its thick atmosphere and revealing its secrets. The Soviet Union's Venera program led the way in exploring Venus with a series of ambitious missions from the 1960s to the 1980s, designed to withstand the planet's extreme temperatures and pressures. Venera 7, in 1970, became the first spacecraft to successfully land on Venus, transmitting valuable data about its surface conditions for 23 minutes before succumbing to the heat. NASA's Mariner program also made significant contributions to our understanding of Venus. Mariner 2, in 1962, became the first spacecraft to successfully fly by Venus, confirming its high surface temperatures and providing the first close-up views of its atmosphere. Mariner 10, in 1974, captured the first detailed images of Venus's cloud cover, revealing its complex and dynamic nature. While the Venera landers provided invaluable snapshots of Venus's surface, it was NASA's Magellan mission that truly unveiled the planet's global topography. Launched in 1989, Magellan's radar pierced Venus's thick cloud cover, creating detailed images. Magellan orbited Venus for over 4 years, building a global map of unprecedented detail. The images revealed a world shaped by volcanic activity, with vast plains, towering shield volcanoes, and intricate fractures. Magellan's data suggested past tectonic activity, reshaping Venus's surface over time. The mission painted a picture of a dynamic, ever-changing world. Building on the legacy of Venera and Magellan, a new generation of missions has continued to unravel the mysteries of Venus, focusing on its dynamic atmosphere, its interaction with the solar wind, and the potential for past or present volcanic activity. These missions, equipped with advanced instruments and leveraging new technologies, have provided fresh insights into this enigmatic world. The European Space Agency's Venus Express, launched in 2005, spent over 8 years orbiting Venus, studying its atmosphere in unprecedented detail. Its instruments measured the composition, temperature, and circulation patterns of Venus's atmosphere, providing valuable data about its superrotation, its greenhouse effect, and the processes that drive its weather patterns. Japan's Akatsuki spacecraft, launched in 2010, joined Venus Express in orbit in 2015 after overcoming a challenging journey. Akatsuki's primary mission is to study Venus's climate system, focusing on the dynamics of its atmosphere, its cloud formations, and the mysterious forces that drive its superrotation. Both Venus Express and Akatsuki have provided valuable data about Venus's atmosphere, revealing its complex and dynamic nature. Venus Express's observations of the planet's south polar vortex, a swirling mass of clouds, provided insights into the dynamics of Venus's atmospheric circulation patterns. Akatsuki's instruments, designed to observe Venus in ultraviolet and infrared light, have captured stunning images of the planet's cloud tops, revealing intricate wave patterns and other atmospheric phenomena. These observations have helped scientists understand the processes that drive Venus's weather patterns and the role of its thick atmosphere in shaping its climate. The data from these missions have also shed light on the interaction between Venus's atmosphere and the solar wind. Venus Express observed how the solar wind strips away gases from Venus's atmosphere, contributing to its evolution over time. Akatsuki's observations have provided insights into the formation and behavior of Venus's magnetotail, a region of magnetized plasma that trails behind the planet as it interacts with the solar wind. The quest to understand Venus is far from over. Past missions have provided invaluable insights into its extreme surface and turbulent atmosphere. A new generation of explorers is poised to launch, equipped with advanced instruments to unlock Venus's secrets. These missions will delve deeper, mapping Venus's surface and searching for signs of life. The coming decades promise a golden age of Venus exploration, shedding light on its evolution and that of rocky planets. Among the most anticipated of these future missions is NASA's Deep Atmosphere Venus Investigation of Noble Gases, Chemistry and Imaging Plus, or Da Vinci Plus, selected as part of NASA's Discovery program. This ambitious mission, slated to launch in the late 2020s, will send a probe plunging through Venus's thick atmosphere, collecting unprecedented data about its composition, structure, and evolution. Imagine Da Vinci Plus Descent Capsule, a technological marvel designed to withstand the extreme pressures and temperatures of Venus's atmosphere, descending through the planet's thick clouds, its instruments analyzing the chemical makeup of the atmosphere, measuring its temperature and pressure profiles, and capturing stunning images of the ever-changing cloudscapes. Da Vinci Plus findings will help scientists understand how Venus's atmosphere formed, how it has evolved over time, and the factors that led to its runaway greenhouse effect. The mission will also search for clues about the history of water on Venus, analyzing the isotopic ratios of gases in its atmosphere, which could reveal whether Venus once harbored oceans like those on early Earth. The other mission, Veritas, will map Venus's surface in unprecedented detail. Equipped with radar, it will reveal Venus's geological features and history. These images will be more detailed than Magellan's, showing features as small as a football field. Veritas will help study Venus's volcanic, tectonic, and impact history. Da Vinci Plus and Veritas represent a new era of exploration for Venus. Future missions might include balloons, rovers, or sample return missions. The future of Venus exploration is bright with promise. From a bright beacon in our night sky to a world of scorching temperatures and crushing pressure, Venus has fueled our curiosity for centuries. Simple observations evolved into a quest to understand this enigmatic world and its tumultuous past. Venus reminds us that our solar system is a place of incredible diversity. Perhaps amidst the swirling clouds, Venus may hold the answer to one of humanity's most profound questions. The journey of discovery is far from over. As we continue to explore the wonders of our solar system, I'm curious to know, if you could send a mission to Venus, what would you want to discover or explore first? Is it the possibility of microbial life in the clouds, the secrets of its volcanic landscape, or something else entirely? Let me know in the comments below. If you enjoyed this journey to Venus, don't forget to give this video a thumbs up and share it with your friends and subscribe to our channel. And if you haven't already, ring the bell so you won't miss the next episode in our Solar System's Wonders series, where we'll be taking a closer look at our very own planet Earth. You won't want to miss it. Until next time, keep looking up.